people might have, so it should be recording now. And I have received several questions about the final project by email, so let's cover them today, and then I will show you 2 or 3 things that might be helpful for you when you are working on the final project. So this is what you should be working on, and I hope you have already been able to open the Pack and Go file successfully and it's working okay. And there are some paths and targets already in the model, but you don't have to use them. You can use them if there's something that you can benefit from, but I think that you can just throw them away and create everything from scratch. So it might be even easier for you that way. So pretty much the only thing that you need are the instructions that I provide in the main function, like how to open the door of the milling machine and how to set the gripper and so on. So what I would do if I started this kind of project, I would first create work object for both pallets. That would make your life quite much easier. And then I guess I would like to have some kind of counter to count how many workpieces we have been handling so far. And after that, it would be just one big loop. It can be a for loop or it can be a while loop. Maybe I would start with a while loop and make it so that it will loop 8 times because we have 8 workpieces on the pallet. I will most likely create a new procedure for the first pallet, so where it picks the part from the pallet, that would be one function or one procedure, and another function would be part to machine or whatever you wish to call it, so where it brings the part to the machine and closes the door and does everything related to that. And when we are done with the machine part, you will just use an if instruction to see if the counter is a multiple of 3, because you should check every third part with the measuring machine. And if the counter is a multiple of 3, then you will just run this measuring machine or some other procedure and drop the part on the measuring machine table and wait a couple of seconds and then grip it again. And after that, you will run part to pallet function that will bring the finalized part on 3x3 matrix on the pallet. And then you will start the loop again and again and again until you are finished with the parts. So in theory, it is actually very simple. In practice, it might take some time because there are some details that you need to work on, and it's not. This is quite simple, but it's quite complicated at the same time. So you need to work on that for a while. And to get you started, I will share some ideas with you. So maybe this is the kind of structure that you also want to have. If you don't have any better idea, maybe it's a good idea to follow some kind of this kind of structure. So this should be good enough for you. Of course, you can select these names as you wish, so it doesn't matter. Make them good names so that they are descriptive, so you yourself understand what they are doing, so it's easier to debug the code and see where the code is going if you have easy to understand names. So instead of having function 1, function 2, function 3, please name them to make some sense. But maybe the most difficult thing in this exercise is handling the pallets so that you will have one 4x2 matrix and another pallet will be 3x3 matrix, and you need to put the parts in or pick the parts from the pallet. And there is one very simple way that you can use, but I don't recommend that. So you can just create a huge program that will have all the so it won't have any loops. It will just be one long copy-paste program, and you will program all the points by hand. But please don't do that. You can do that if you want to, but most likely you don't want to be doing that, because it will take quite a long time, and it's very difficult to debug if you need to change something. So it's much easier to use a loop and use some kind of calculations to define the places for the parts, where to pick them up or where to put the parts to the pallet. And we have already covered pretty much all of these main things, so you have been using div and mod. They might be quite helpful here. You have been using offsets. They will be helpful, I guess. You have been using object frames in work object, and you can use them here also. You have been using rel tool. That can be used as well. Maybe it's not necessary, so I will show you how I would like to do this myself, and I most likely wouldn't be using rel tool in any way, because this just doesn't require that. And also, if you don't like to use div and mod, you can maybe create a long array and just hold the offset values, so for x and y for both pallets. So let's see. If you want to pick the first part, you will use the first part of both arrays as offset, so it would be 0 and 0. And the second part would be x0 and x300 and 0 would be for y, and the third part would be maybe 400 for y and 0 for x, and so on. So you can do this kind of array by hand. Again, not that much recommended, because it takes quite much time and it's not too easy to debug or change. But if you can't make it work with div and mod or some other functions, then you can create this also. So just create a long enough array that holds all the values for offsets for both x and y for both pallets, and it should work okay. But let's talk a little bit about div and mod that we covered last week, or actually last Monday. So after last week, we had quite many questions about div and mod, and I showed you this slide on Monday. So if we have these 14 yellow dots, and we try to visualize what div and mod mean, 14 div 4 equals 3, because you can fit these boxes of 4 exactly 3 times in the sequence of 14 dots. And after these 3 boxes, you will have 2 dots left, and this would be the result of the mod. Okay, and if we flip this like so, it will look a little bit more like our palette. So we will have these div blocks here, and the mod shows us the remainder of the parts. And let's take the picture of our palette and compare it to that. So you can also use div to see how many blocks of 2 pieces you have, and you can use mod to see what is the remainder after you have been picking all these parts away. And it might be easier to understand if I show you in Robot Studio. So I will start sharing my desktop, and I will show you in Robot Studio a couple of things, and then we should be okay. Yep, now it should be working. So here I have the same window or the same program that you have, and I haven't done anything here yet. So first I will just create one point somewhere close to the paths, and let's try creating this div and mod thing for this first palette here. So I'll just take the robot and move it, and I will also select the tool, correct tool here. And if I want to, I can use this snapping tool that snaps to object, center, mid, and end points. So I can just use this and drag down, and it should be so that the tool center point is in the middle of the path. The bad thing here is that the tool center point is a little bit lower, or actually it's not exactly in the bottom of the vacuum cup, so our vacuum cups go inside the path. So I will just raise it a little bit up. Okay, and you can define these in better detail, but we will just do it roughly this time. And also, as you can see, these vacuum cups are in a bad orientation, so they are not. We should rotate the tool 90 degrees to have it a little bit better, but let's do that also. Oops. Okay, again, I'm doing it just roughly, so it's not precise yet, but it will be good enough for today's demonstration. And here I will just teach a target. Okay, we created a target now, and then I will go here to paths and targets, and it will be this one here. And I need to create a path of this. It will be path number 10, and that's good enough for me. And the reason I created the path is that when we synchronize that to Rapid, it will only synchronize the targets that are that belong to some path. So that's the reason why let's see, I need to change the screen sharing settings for a while because this is causing some trouble for me. So I need to share my complete desktop instead of just one. Okay, now it should be working because, yes, now it's working correctly. Because a while ago it was closing the windows for me all the time and it was confusing. So I will only synchronize this path number 10 and click OK. And then let's go to Rapid View and click this module 1. And again, I'm having this main module and module number 1. You can, if you want to, you can copy all these to the main module, or you can keep them separate. I think I will keep them separate for now. And I can change this to be like big part, for example. And let's go to main module and call the big part function. Okay, so now every time that I start the simulation, it will run our big part function, and I will select new vertical tab group to have the 3D view and the code view at the same time. And then I need to, yes, okay, so I need to do this to change our code. And what I want to do next is that I need to create a couple of variables. So we want to have a numeric variable of n counter, for example. This could be our counter, and then I need to have a variable for x and y that will hold the results of the div and mod operations, and that will tell which path to pick next. So let's create them also. Let's call them n, x, and again, I will use this n prefix just to help me to remember that these are numeric variables. So it's not too important to do that, but it makes the code look a little bit nicer. And what I'm going to do here is that I will use the offset function. And I will just make this so that the first line will be with offset 100 millimeters for axis Z, and the last line again the same thing, and the middle line won't have any offset for now, and then we will have a wait time for maybe 1 second here. And now if we try to run it, it should go up and down and wait for a while and then go up again. And let's see if it's working okay. Oh, I think we need to click this apply. Let's see, apply. And then it says that we don't have any errors on the code, and let's click play. Yeah, so it went up and then down, waited for 1 second, and then went up again. Okay, that's good enough. And then we can start working with the div and mod functions. But first, let's create the while loop. So while n counter is less than 8, for example, do something, and we need to end the while loop over here. I will indent them to make it look a little bit better, and here I think I need to reset the n counter so it will start with 0, and at the end of the loop I need to increment the n counter, of course, so the loop won't run forever. And let's try it again. So if I click start, it should run this 8 times, I guess. Whoops, the simulation is running again, so let's click stop, and then let's try again. So now it should be going 8 times, and it looks like it's working okay. And what we need to do now is that we need to make it move the robot somewhere. So we need to utilize these offsets here. So in each loop we want to do something for the n counter variable, and let's try it so that I will put that the nx equals n counter div 2, and 2 because we have 2 pieces side by side. Okay, so nx equals n counter div 2, and it doesn't do anything yet, but we want to use this nx variable in these offsets, and this first value is x and then y and then c, so let's use it here, and let's put like nx times 200 so we will see the motion correctly. And now it should be doing something, and you can try to figure out what it's supposed to do, but let's see. Let's try what it's doing now. So 1 time here, again here, then it moves and does 2 times over there, and we don't have to be too worried that it's going to the wrong direction, because that will be fixed when you set up the object frame or the work object in the corner of the palette. Okay, so now it's doing okay, and if you try to remember the functions of div, that's exactly what it's supposed to do. So it did 2 pieces in this first row, and then 2 times in the second row, and 2 times in the third row, and again 2 times in the fourth row. And now we just need it to move back and forth between this left and right part. And as you remember, we can use mod to find out the remainder of this calculation. So we can just use n y equals counter mod 2, and again we can just use here for offset ny times 200, for example. And now it's supposed to do something better. So let's see if it's working. One time here. Yes, and now it is working pretty much perfectly. So it is using the encounter variable that just holds the information of what is the ID number of the workpiece that we are handling right now, and it's calculating the offset based on that value. And you don't have to be worried that it's going to the wrong direction, because you can just use some corrections here, or you can fix it by setting the correct work object or whatever you wish to do. But this is the way you can do it. What I would like to change here is that this looks quite ugly now that we have these long offset lines here. We need to have this offset in every single line, and it's quite long and it's looking quite ugly. So I would propose that you start using the object frame of the work object. And if you don't remember how that works, you can check up the earlier week tutorials and exercises and practice the use of object frame, so it will make it much nicer. But this is the very basic principle, and we can actually try, if we want to use this on 3x3 matrix, we can just set it so that we will have 3 pieces side by side, and maybe it will work nicely here. Well, it didn't work nicely here because the robot went too close to its own base, but let's change these to be 100 and try it again. Oh, of course, because I'm changing the wrong coordinates. Let's try it once more. Yes, so that's actually how easy it is to change from 4x2 matrix to 3x3 matrix using div and mod. So I think that would be pretty much all the information that you need right now. And then we can also try one more thing. So, because you need also to have the distances between these parts. So let's try that also. And I think after that, we are pretty much done with the introduction. So then you can continue working on your own. And if you run into some problems, just use the Facebook group to discuss with the fellow students so they can help you out. But if you go to the modeling tab, you have these point-to-point measuring tools. And then you can activate this snapping here. So if you want to measure the distance between the workpieces, we can just click on one corner and then the next one, and it will show that this is 400 millimeters in this direction. And we can then measure the other direction, and it shows that it will be 300 millimeters. So maybe I will send you these distances so everybody can use the information. But if you need to measure something in the model, it can be done with the modeling view and the point-to-point measuring tools. And it's a very good idea to use these snapping tools so that you can snap to correct places. If you have some questions now about the final project or something that you want to discuss, we can discuss them briefly. Or if this is enough information for you, then we can just stop the recording and you can continue working. And okay, let's see, there's some some comment coming in. But the final project, it shouldn't be too difficult for you, so it will be quite challenging. Okay, and there were some issues with the I/O of the CNC. Can you describe in more detail what kind of problem did you have? And also, I think that maybe we can stop the recording now and we can just continue by chatting. So I will quit the recording now.